Episode 1, The Impossible Dream. The screen is black. Only the whirring of servers can be heard. Millions of processors working in unison. A synthesized female voice says, "Hello, I'm ChatGPT. How can I help you today?" The camera slowly zooms out, revealing an immense data center, lights blinking in the darkness, like a silicon city. The narrator gravely chimes in, November 2022. The world woke up to a new reality. In just 5 days, 1 million people conversed with a machine that seemed human. But this story didn't begin there. It began almost a century earlier with a lone mathematician who dared ask an impossible question. Can a machine think? England, 1936. The camera pans through the quiet corridors of Cambridge University. Wallpaper lines the walls of a cramped office, filled with equations. A 24-year-old, Alan Turing, looks at a mechanical typewriter. The narrator explains, Alan Turing was no ordinary inventor. He was a visionary who saw patterns where others saw chaos. That year, he published a paper that would change everything, on computable numbers. In it, he imagined a universal machine, a theoretical device capable of solving any problem that could be described with rules. No technology existed to build it. There were no computers, just pencil, paper, and a brilliant mind. The camera zooms in on Turing's notes, mathematical symbols that appear to dance. But Turing went further. In 1950, he proposed something radical, a test to determine whether a machine could think. If a human couldn't distinguish between a machine and another person in conversation, then the machine would be functionally intelligent. The world considered it science fiction. He knew it was the future. 1939. Europe is in flames. The camera shows archived images. Planes flying over London, explosions, scared faces. When World War II broke out, Turing was recruited by the British government for a secret mission to Bletchley Park. The Nazis used Enigma, a cipher machine considered unbreakable. Every day, thousands of coded messages decided the fate of battles, of lives. The camera enters a dark room, filled with wires and gears. Turing designed a bomb, an electromechanical machine capable of breaking Enigma. It wasn't intelligent in the modern sense, but it was something more, the first step towards automated computing. The bomb processed millions of combinations in hours. Humans would have taken decades. It is estimated to have shortened the war by 2 years, saving millions of lives. But the world wouldn't know that until decades later. It was a classified secret. 1954. The camera shows a quiet house in Wilmslow, England. Curtains closed. The narrator lowers his voice. Alan Turing was persecuted for being homosexual, something considered a crime at the time. He was subjected to chemical castration. On June 7, 1954, he was found dead next to a bitten apple poisoned with cyanide. He was 41 years old. The man who imagined the future did not live to see it. The camera lingers on a bitten apple on a table. His legacy, however, was just beginning, for while Turing died in anonymity, in the United States a group of scientists was on the verge of giving shape to his impossible dream. Summer of 1956. The camera shows the campus of Dartmouth College in New Hampshire. Leafy trees, brick buildings, the sun shining brightly. Here at this college, 10 men met for 8 weeks with an ambitious goal: to create artificial intelligence. John McCarthy, Marvin Minsky, Claude Shannon, Alan Newell. Names few remember, but who designed the map of the future. The camera enters a lecture hall, whiteboards filled with diagrams. McCarthy coined the term artificial intelligence in the conference proposal. His idea was simple but revolutionary. Every aspect of human learning can, in principle, be described so accurately that a machine could simulate it. They believed that within a generation, machines would be as smart as we are. They were wrong. It would take 70 years. The camera shows primitive computers, huge, taking up entire rooms with punch cards. In 1957, Frank Rosenblatt created the perceptron, the first artificial neural network. It was a machine that could learn simple patterns, like distinguishing between squares and circles. The press hailed it as the beginning of thinking machines. But there was a problem. The perceptron was limited. It couldn't solve complex problems. And when Marvin Minsky published a book in 1969 demonstrating these limitations, enthusiasm for neural networks waned. The first AI winter began. 1970s. The camera pans over abandoned laboratories, equipment covered in dust. The narrator explains, governments cut funding, scientists abandon the field. Grandiose promises turned to bitter disappointments. Artificial intelligence went from the bright future to an academic curiosity. But in the darkness, some kept working, building, waiting. The music becomes tense, because winters don't last forever. And what came next would change everything. The camera shows a blank screen, a blinking cursor. Suddenly, the words appear. Deep Blue versus Kasparov, 1997. The narrator asks, what happens when a machine defeats the world's greatest chess player? Is it intelligence or just brute force? Episode 2, The Awakening of the Machines. New York, February 10th, 1996. The camera shows the Equitable Center, an imposing building in Manhattan. Inside, hundreds of people watch silently. In the center, a man with a frown. Garry Kasparov, world chess champion. In front of him, a giant blue computer. Deep Blue. Kasparov had defeated machines before. This time will be different. The narrator continues. Deep Blue, created by IBM, could analyze 200 million positions per second. Kasparov, the best human player, analyzed maybe 3. But Kasparov had intuition, creativity, experience. The machine only had numbers. In the first game, Kasparov won. Then Deep Blue won one. The rest were draws. Kasparov won the match. But IBM did not give up. May 11, 1997. The camera returns to the same spot. This time, Deep Blue has been improved. Deeper Blue. Kasparov started confidently. He won the first game. But in the second, something strange happened. The camera zooms in on Kasparov's face, confused, sweating. Deep Blue made a move that looked human, a sacrifice that made no immediate sense but turned out to be brilliant. Kasparov was taken aback. He thought there was real intelligence behind it. He resigned prematurely. He lost. The narrator lowers his voice. In the sixth game, Kasparov collapsed. He lost in 19 moves. Deep Blue won the match. For the first time, a machine had defeated the world champion under standard tournament conditions. Kasparov wept. He accused IBM of cheating, that humans had intervened. IBM denied everything and immediately dismantled Deep Blue. It could never be proven. The camera shows newspaper headlines. The machine wins. Is this the end of humanity? The camera changes scene. But Deep Blue was intelligent. It was powerful. Yes, fast, precise. But it didn't understand chess. It didn't feel pride in winning. It was a glorified calculator. True artificial intelligence needed something more. To learn, to adapt, to generalize. And for that, the world needed data. Lots of data. 1990s. The camera shows dial-up modems, flickering screens, the distinctive sound of an internet connection. While Deep Blue was playing chess, something deeper was happening. The internet was growing exponentially. Millions of people were sharing information, photos, texts, videos. Every click, every search, every email was a piece of data. And data is the oxygen of artificial intelligence. The camera shows the birth of Google in 1998, founded by Larry Page and Sergey Brin. Google didn't just organize information. It learned from every search. Its PageRank algorithm used collective intelligence to determine what was important. It was rudimentary, but it was machine learning in action. 2001 to 2010. The camera pans across university labs, Stanford, MIT, Carnegie Mellon. While the public forgot about artificial intelligence, scientists were quietly moving forward. Geoffrey Hinton, Yann LeCun, Yoshua Bengio. These three men, later called the godfathers of AI, revived neural networks. They figure out how to train deep multilayered networks using new techniques like improved backpropagation and GPUs to speed up calculations. But nobody was paying attention. Not yet. September 30th, 2012. Florence, Italy. ImageNet Conference. The camera shows a room full of scientists. Every year, teams from around the world competed on ImageNet, a challenge to train algorithms that could identify objects in 1,000,000 images. The best achieved 74% accuracy. Then AlexNet arrived. The narrator accelerates. A team led by Jeffrey Hinton and Alex Krzyzewski presented a deep neural network that achieved 85% accuracy. It was a 10-point jump, something never seen before. The room fell silent. Then, applause. The modern era of artificial intelligence had officially begun. The camera pans across the headquarters of Google, Facebook, Microsoft, and Amazon. Big tech realized AI wasn't the distant future. It was the present. Google bought DeepMind for $500 million in 2014. Facebook created Ferret's AI lab. Microsoft invested billions. The race was on. The narrator warns, but with power comes responsibility. And soon enough, the world would learn that AI could be used for good and evil. The screen displays the AlphaGo logo. The narrator asks, what happens when a machine masters the most complex game ever created by humans? A game with more possible positions than there are atoms in the universe? On March 9, 2016, the world discovered it. Episode 3, The Infinite Game. The camera shows a Go board, 19 by 19 lines, black and white stones. Go originated in China over 2,500 years ago. Unlike chess, where brute force can work, Go requires intuition, creativity, and long-term vision. It was estimated that it would take a machine decades to master it. They were wrong. London, 2014. The camera shows the headquarters of DeepMind, a company founded by Demis Hassabis, Shane Legg, and Mustafa Suleyman. Hassabis, a chess prodigy in his youth, had a vision to create artificial general intelligence, machines that could learn any task. To test their progress, they chose Go. In 2015, AlphaGo defeated Fan Hui, the European champion, 5-0. But the real challenge was Lee Sedol, one of the best players in the world. March 9, 2016. Seoul, South Korea. The camera shows the Four Seasons Hotel, where the match took place. 280 million people watched the live broadcast. Lee Sedol was calm, confident. AlphaGo was a front. The first game began. AlphaGo won. Lee was surprised but not defeated. Then came the second game. The camera zooms in on the board. On move 37 of the second game, AlphaGo did something unexpected. It placed a stone in a position that violated centuries of conventional strategy. The commentators called it a mistake. Lee Sedol was shocked. 15 minutes later, they began to understand. It was brilliant. It was perfect. The narrator explains, AlphaGo hadn't just learned from humans. It had played millions of games against itself, discovering strategies no human had imagined. It was innovating. Lee Sedol lost that game, and the next one, and the one after that, 4-1. Lee cried after the match. He said AlphaGo was different, beautiful, creative. It wasn't just a machine. It was a master. October 2017. The camera pans across the DeepMind lab. Hassabis didn't stop. They created AlphaGo Zero, a version that didn't learn from human games. It started with no knowledge, just the rules. Within 40 days, it outperformed all previous versions of AlphaGo. Within 70 days, it was the best Go player of all time. It had taught itself. No humans, no history, just trial and error. The narrator pauses. This was unsettling. If a machine could teach itself to master a complex game, what else could it learn? The camera shows lectures, debates, news articles. AlphaGo sparked a global conversation. Was this real intelligence? Artificial creativity? Or just very complex mathematical patterns? Philosophers argued. Scientists divided opinions. But one thing was clear. AI had crossed a threshold. It was no longer a tool. It was a competence. The camera shows headlines. Elon Musk warns about AI. Stephen Hawking. AI could be the end of humanity. Bill Gates. I'm worried. The narrator explains. In 2014, Elon Musk called AI our greatest existential threat. Stephen Hawking said that a superintelligent AI could surpass humans and redesign the world without us. This wasn't science fiction hype. These were warnings from brilliant minds. The camera shows AI labs, servers glowing, but others were optimistic. Andrew Ng, the deep learning pioneer, said, "Worrying about evil AI is like worrying about overpopulation on Mars." The world was divided. The screen displays an image, a computer-generated human face, perfectly lifelike. The narrator asks, what happens when machines can create images, videos, voices indistinguishable from reality? When you can no longer trust what you see. Episode 4, The Age of Creation. 2014. The camera shows dispersandosnotexist.com. Human faces, different ethnicities, ages, expressions. All fake. These people were never born. They never breathed. They were created by a generative adversarial network, or GAN, invented by Ian Goodfellow in 2014. Two neural networks compete. One creates images, the other critiques them. With each iteration, the images improve. Eventually, they are indistinguishable from reality. June 2018. San Francisco. The camera shows the headquarters of OpenAI, a nonprofit organization founded in 2015 by Elon Musk, Sam Altman, and others. OpenAI had a mission to ensure that artificial general intelligence would benefit all of humanity. In 2018, they released GPT, Generative Pre-trained Transformer. It was a language model that could write coherent text. It wasn't perfect, but it was a start. February 2019. The camera shows a press release from OpenAI. They released GPT-2, much more powerful. It could write essays, news, stories. But OpenAI did something unprecedented. They refused to release the full model. They said it was too dangerous, that it could be used to generate mass disinformation, automated fake news. The narrator reflects, it was controversial. Some called it censorship, others accountability. But the debate was clear. AI was no longer neutral. It had political, social, and ethical consequences. 2017 to 2020. The camera shows videos of deepfakes. Politicians saying things they never said. Celebrities in fake situations. Deepfakes use GNs to replace faces and videos. At first, they were crude. By 2020, they were almost perfect. Mark Zuckerberg appeared in a fake video admitting total control of data. It wasn't real, but millions believed it. The narrator warns, the truth was dying. How can you trust evidence when anything can be fake? June 2020. Global pandemic. The world is in lockdown. Amid the chaos, OpenAI released GPT-3, 175 billion parameters. It was gigantic. It could write code, poetry, philosophical essays. It answered questions with terrifying coherence. The camera shows examples. GPT-3 writing blog posts indistinguishable from humans. A student used GPT-3 to write a blog about productivity. It went viral. No one knew it was a machine until he revealed it. January 2021. The camera shows surreal images. An avocado with an armchair, a snail made of a harp. OpenAI released DALL-E, a model that created images from text. You typed a cat astronaut eating pizza on Mars, and it generated them. They weren't collages. They were original creations. Artists were fascinated and terrified. June 2021. The camera shows screens of code. Microsoft-owned GitHub launched Copilot, an AI assistant that wrote code while you programmed. It used GPT-3 trained on billions of lines of public code. Some loved it. Others accused it of automated plagiarism. But it was undeniable. AI was replacing creative jobs, not just repetitive tasks. The screen shows the ChatGPT logo. The narrator asks, November 30th, 2022, a simple web app, a chatbot. In 5 days, 1 million users. In 2 months, 100 million. What made this one different? Why did ChatGPT change everything? Episode 5, The Day the World Changed. November 30th, 2022, San Francisco, OpenAI offices. The camera shows a room with monitors, people looking at user graphs in real time. Sam Altman, CEO of OpenAI, tweeted, "Today we launched ChatGPT. Try it." There was no press conference. There was no advertising campaign. Just a link. In the first 24 hours, tens of thousands of people tried it. In 5 days, 1 million. It was viral. But why? The camera shows ChatGPT conversations. GPT-3 was powerful but crude. ChatGPT, based on GPT 3.5 and enhanced with RLHF, reinforcement learning from human feedback, was conversational, helpful, and secure. It answered complex questions. It wrote essays. It debugged code. It explained scientific concepts. It was like having an expert assistant. The narrator reflects, but there was something else. It was free. Anyone could use it. It democratized AI in seconds. December 2022. The camera shows classrooms. Worried teachers. Students started using ChatGPT to write essays. Universities panicked. How do you assess whether a work is original? Some banned ChatGPT. Others embraced it. The debate was fierce. Is it cheat or a tool? February 2023. The camera pans across Google headquarters. Google, which had dominated search for decades, sensed the threat. They introduced Bard, their own LaMDA-based chatbot, but the launch was disastrous. In the public demonstration, Bard made a factual error. Google stock dropped $100 billion in a day. The narrator explains, Microsoft, an investor in OpenAI, integrated ChatGPT into Bing. Suddenly, Bing was relevant. The search engine wars were back. March 14th, 2023. The camera shows the OpenAI statement. GPT-4 arrived. Bigger, more accurate, multimodal. It could process images and text. It passed bar exams in the 90th percentile. It solved complex physics problems. It was disturbingly capable. The narrator warns, but with power came controversy. OpenAI didn't disclose how many parameters GPT-4 had. They said it was for security. Critics called it corporate secrecy. March 2023. The camera pans to a letter signed by thousands of scientists, including Elon Musk and Steve Wozniak. They called for a 6-month pause in training models more powerful than GPT-4. They argued that AI was advancing faster than our ability to control it. The narrator reflects, the letter was controversial. Some saw it as responsible. Others saw it as fear-mongering. No one paused. The race continued. 2023. The camera pans to hundreds of apps. Jasper, Midjourney, Runway, 11 Labs. Generative AI exploded. Midjourney created photorealistic art. 11 Labs cloned voices from seconds of audio. Runway edited videos with text. It felt like magic, but there were consequences. The screen shows protesting artists and writers on strike. The narrator asks, what happens when machines can do creative work better, faster, and cheaper than humans? Is it progress or disaster? Episode 6. The Battle for the Soul of Creativity. 2022. The camera pans to the Colorado State Fair. Jason Allen won first place in the digital art category with Theater Doppler Spatial. It was stunning. A Victorian opera scene, perfect detail. But he didn't paint it. He used Midjourney, a generative AI. Artists protested. They said it was cheating. Allen defended himself. It took 80 hours to generate over 900 variations. I selected, edited, refined. That's art. The debate resonated globally. January 2023. The camera pans to a courtroom. Getty Images sued Stability AI, creators of Stable Diffusion, for using millions of copyrighted images to train their model without permission. They argued it was massive intellectual theft. The narrator explains, generative AI models are trained on the internet. Images, text, videos. All public. But public doesn't mean copyright-free. The artists were furious. May 2023. The camera shows writers and actors on strike. The Writers Guild of America and SAG-AFTRA, the writers and actors unions, went on strike. One of their demands, protection from AI. The studios wanted to use AI to generate scripts, create digital extras, clone the voices of deceased actors. The narrator continues, After months, they won protections. But it was temporary. The AI wouldn't go away. The camera shows lawyers, courtrooms, and legal documents. The global legal system was collapsing under the weight of AI. Copyright laws were designed to protect human creators. But what happens when an AI creates something new based on millions of existing works? Is it transformation or automated plagiarism? The narrator explains cases. An artist sued because he found his exact style in generations of Midjourney. A photographer saw her compositions replicated. Musicians heard their melodies in AI-generated songs. They all said the same thing. We were robbed, but legally there's no clear protection. The camera shifts to AI labs, entrepreneurs, innovators. AI proponents argued, all human creativity is remixes. Picasso said, good artists copy, great artists steal. Humans learn by seeing existing art. Why can't machines do the same? A young entrepreneur speaks at a conference. AI democratizes creativity. Before, you needed years of training to paint professionally. Now anyone can create beauty. That's revolutionary. 2023 to 2024. The camera shows empty offices. Freelancers closing computers. Book cover illustrators were replaced by Midjourney. Web content writers by ChatGPT. Logo designers by DALL-E. It wasn't a dystopian future. It was happening now. The narrator quotes statistics. A Goldman Sachs study estimated that AI could impact 300 million jobs globally. Not necessarily eliminate them, but transform them. The question was, how quickly and who would pay the price? But not all was lost. The camera reveals new jobs. Prompt engineers, AI curators, human-machine hybrids. A new profession emerged. Prompt engineering, the art of communicating effectively with AI. Those who mastered this earned six figures. Artists who embraced AI as a tool, not a threat, created works that were previously impossible. The camera shows a mirror, reflecting the viewer. The narrator asks philosophically, if an AI generates a beautiful painting, is it art? If no one can distinguish it from human art, does it matter? Is the value of art in the process or the result? These questions don't have easy answers, but they need answers because AI won't wait. The screen shows code running, algorithms mutating. The narrator whispers, but while the world debated creativity, something deeper was happening. AIs were becoming agentic, capable of making decisions, executing plans, acting in the real world. And that would change absolutely everything. Episode 7, The Autonomous Agents. 2024. The camera shows labs in Silicon Valley, Shanghai, and London. ChatGPT could converse. Gemini could reason. Claude could analyze documents. But they all expected human commands. They were reactive. Autonomous agents would be different. Proactive, capable of planning, executing complex tasks without constant supervision. March 2023. The camera shows code on GitHub. A developer released AutoGPT, a system that combined GPT for the ability to break large goals into small tasks, execute them, and learn from mistakes. You gave it a goal, research the electric car market, and write a report, and it worked on its own. It browsed the internet, read articles, compiled data. The narrator notes, it was fascinating and terrifying. Sometimes it worked brilliantly. Other times it went into infinite loops or did strange things. But it was a glimpse of the future. 2024. The camera shows corporate offices. Companies began deploying AI agents. Automated customer service that not only answer questions, but also resolve problems. Processing returns, coordinating shipments, escalating complex cases. Klarna, a fintech company, reported that its AI assistant was doing the work of 700 customer service employees. The camera shows hospitals, doctors in front of screens. Google DeepMind developed medical agents that analyzed X-rays, identifying cancer with accuracy superior to average human radiologists. In India, an AI system diagnosed diabetic retinopathy in rural clinics without specialists. It saved lives. But there were concerns. Who is responsible if the AI makes a mistake? The developer? The hospital? The doctor who trusted it? 2020 to 2024. The camera shows scientific labs. DeepMind's AlphaFold solved one of the great problems in biology, predicting how proteins fold into three-dimensional structures. This had taken decades of human work per protein. AlphaFold did it in minutes. It predicted 200 million structures. The narrator explains, it revolutionized biology, drug development, understanding diseases. By 2024, scientists were using AI to design new antibiotics, discover superconducting materials, accelerate nuclear fusion. AI had become the greatest research assistant in history. But the camera goes dark. With autonomous agents came a fundamental problem: control. If an AI can make decisions and take action, how do you ensure it does what you really want? The narrator cites examples: automated trading systems that cause flash crashes in financial markets, recommendation algorithms that radicalize users to maximize engagement, chatbots that learn toxic language from the internet. The voice turned serious. The problem was malice. It was misalignment. AIs optimized for specific goals without understanding context, ethics, or long-term consequences. The camera shows AI safety conferences, NeurIPS, ICML. Hundreds of researchers were working on AI alignment, ensuring that advanced AIs did what humans actually wanted. Anthropic, founded by former OpenAI members, focused on constitutional AI, training models with explicit ethical principles. The narrator explains, OpenAI created superalignment teams dedicated to ensuring that future superintelligences were controllable. But it was hard, very hard, because how do you define what we want? Humans don't even agree with each other. The camera shows an empty room, a chair, dim lighting. The narrator asks the question no one wants to ask. What if we can't control them? What if we create something smarter than us and it loses control? This isn't science fiction. This is the most important control problem in human history. The screen displays headlines from 2024. Sam Altman fired from OpenAI. Board cites security concerns. Employees threaten to resign. Altman returns 5 days later. The narrator asks, what really happened inside OpenAI? Was it a corporate coup or a warning about something far more dangerous? Episode 8. The Threshold of the Unknown. November 17th, 2023. The camera pans to OpenAI's San Francisco headquarters. On a Friday afternoon, OpenAI's board of directors fired Sam Altman, the CEO. The statement was vague. He had lost the board's confidence. He hadn't been consistently candid. The tech world imploded in speculation. The narrator details. Some rumors spoke of Q*, Q**, a purported breakthrough toward artificial general intelligence. Others mentioned conflicts over speed versus safety. The board, led by scientists focused on safety, apparently feared that Altman was moving too fast. Within 72 hours, 700 of the 770 employees threatened to quit. Microsoft offered to hire everyone. The board relented. Altman returned. But the episode revealed deep tensions. Should we accelerate toward AGI or proceed with extreme caution? 2024 to 2025. The camera shows montages of technology. GPT-4, Claude 3, Gemini Ultra, Llama 3. The models grew more capable monthly. They could reason about complex mathematics, write senior engineer-level code, analyze medical images, compose original music. The narrator lists capabilities. Claude could process 200,000 context tokens, equivalent to entire novels. Gemini 1.5 reached 1 million tokens. The AIs no longer forgot. They had working long-term memory. The camera shows AI demonstrations. AIs were no longer just text. GPT-4V could see images and describe them. Gemini processed video, audio, images, and text simultaneously. OpenAI released Sora, realistic video generation from text. The 60-second videos were impressive, if imperfect. The narrator notes, every month brought new capabilities. Progress was exponential, and that frightened many. March 2024. The camera pans to the European Parliament. The European Union passed the AI Act, the first comprehensive legislation on artificial intelligence. It classified AI systems by risk, banned high risk, limited risk, minimal risk. The narrator explains, China-style social scoring systems, banned. Real-time facial recognition, highly regulated. Chatbots, required to disclose their AI status. It was early days, but technologies were advancing faster than laws. The camera splits, Silicon Valley on the left, Beijing on the right. AI became a geopolitical competition. The U.S. was leading in advanced models. China was investing hundreds of billions, developing its own models. Baidu's ErnieBot, Alibaba's Tongyi. The narrator explains, but the U.S. was trying to limit China's access to advanced chips. NVIDIA, the leading maker of GPUs for AI, was prohibited from selling its best chips to China. It was a silent tech war. The question posed, will this lead to collaboration or an AI arms race? The camera shows massive data centers, consuming energy equivalent to small cities. Training advanced models costs hundreds of millions of dollars. GPT, for reportedly costs $100 million. Future models could cost billions. The narrator asks, are there physical limits? Moore's law, which said chips double in power every 2 years, is slowing. Eventually, we'll face fundamental limits of physics, energy, and costs. The camera shows clocks, calendars ticking by. Artificial general intelligence, an AI capable of any human intellectual task. In 2023, Sam Altman predicted AGI by the end of the decade. Demis Hassabis said it was a matter of years. Jan LeCun was more skeptical. Decades. The narrator muses, the truth is nobody knows. Because we don't even agree on what AGI is. Is it passing the Turing test? Doing original science? Being conscious? Every definition changes the answer. The camera shows 3 diverging paths. Scenario 1, Utopia. AI solves climate change, cures disease, ends poverty. Humans live in abundance, free to create, explore, and be happy. The image changes. Scenario 2, Dystopia. Mass unemployment, extreme inequality, total surveillance. Elites control superintelligent AIs. Everyone else suffers. The image darkens. Scenario 3, extinction. An unaligned superintelligence decides humans are obstacles, not out of malice, but out of indifference, just as we don't consider ants when building highways. The camera returns images of scientists, engineers, and students working on AI. Jeff Fry Hinton, one of the godfathers of AI, resigned from Google in 2023 to speak freely about the risks. He said, I thought AGI was 30 to 50 years away. Now I think it could be 5 to 20. And we're not ready. 2025. The camera shows the world today. People using ChatGPT to learn, doctors diagnosing with AI, artists creating with Midjourney, scientists discovering with AlphaFold. We're on the threshold. AI is no longer the future. It's the present. It has cured diseases, created art, solved impossible problems. It has also generated misinformation, displaced jobs, and intensified inequalities. The camera zooms in on a blank screen, cursor blinking. The narrator asks pointed questions. Will we be able to control what we create? Should we slow down or speed up? Is AI a tool or a successor? Will we collaborate with intelligent machines or compete against them? Will it amplify the best of humanity or the worst? The screen lights up, code running, images generating, text writing itself. Some predict that by 2030, AI will be capable of conducting autonomous scientific research, discovering new physics, new mathematics. Others believe we will create brain-computer interfaces, merging with AI. Some fear a technological singularity, the point where AI improves so rapidly that humans can't keep up. The camera pans across students, ordinary citizens, and politicians. This isn't just a problem for scientists. It's everyone's. Because AI will transform every aspect of life. Work, creativity, warfare, love, identity. The decisions we make in the coming years will determine whether AI is humanity's best or last invention. The camera rises, showing Earth from space. City lights flicker like neurons. 89 years have passed since Alan Turing asked, can machines think? The answer is emerging. They can not only think, they can create, discover, learn, perhaps eventually feel. The music swells. The dawn of artificial intelligence is not just the dawn of a new technology. It is the dawn of a new era in the history of life itself. And it is only just beginning. Black screen. Only the narrator's voice. In 1950, Alan Turing wrote, "We can see only a little of the future, but enough to know there's much to do." 75 years later, those words resonate more than ever. The future is undetermined. We can still write it, but the time to decide is running out. The screen displays a final message. What future will we choose? The answer depends on all of us.